Section 1.1 is finding and describing patterns. Geometry and math in general can be described as a process of using logic and finding patterns. And this process is called inductive reasoning, which we'll look at a little bit more in section 1.2. So we're going to look at patterns. Describe the pattern the figures follow from left to right, then sketch the next figure. So you can see this first triangle has 3 sides, the next figure has 4 sides, 5 sides, and then 6 sides. So my next figure is going to have 7 sides. So we're going to draw a figure with 7 sides. Okay. So we want to describe the pattern. The number of sides increases by 1. So we started with 3 sides, we had 4 sides in the square, 5 sides, 6 sides, and now we have 7 sides. Okay. Next pattern, we have 2 equal parts, now we have 3 equal parts, now we have 4 equal parts, so in this next circle we're going to have 5 equal parts. Okay, hopefully yours looks a little better than mine. So we have 5 equal parts, so the pattern, equal parts of the circle increase by 1. Okay. Next one we have, looks like a sun. We have a circle and some petals. So notice we have some petals that are shaded. And the shaded triangle moves 1 space to the left each time. So let's try to draw this again. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so started up here, went 1 to the left, 1 to the left, so now we want to shade this petal. So the shaded triangle moves 1 space, and in math, when we talk about moving left and right, we can use the words clockwise or counterclockwise to describe the direction. So shaded triangle moves 1 space in a counterclockwise direction. This next example, we have a circle with the top half shaded. Now we have 4 equal parts with the top left part shaded. Now we have a circle with 6 equal parts with the top left part shaded. So we have 2, 4, 6. So our next circle is going to have 8 equal parts. Okay, that was not the best, but something like that. And we're going to have the top left part shaded. Okay, we'll look at a couple more patterns. Here we have a square, then we have a square that's rotated inside, then we have a square that's upright inside of that square. So here, a square. And then the upright square. And then we need to do one more square inside that's rotated. Let's look at some patterns in numbers. To describe patterns in numbers, you want to figure out, am I adding the same amount every time? Am I multiplying the same amount every time? Then we're going to look at something called consecutive integers. So in this first example, 3 to 6 could either be multiplying by 2 or adding 3. So let's check the next one. 6 to 9. Okay, now we know that we're adding 3 every time. So plus 3, this is plus 3. 9 plus 3 is 12. 12 plus 3 is 15. So how do I describe that? We're going to say add 3 to the previous term. Let's look at another pattern. Again, we have 3, 6, but now we have 12. So instead of adding 3, we can see 6 to 12 means that we're multiplying by 2. So this is times 2, times 2, times 2, times 2. So to describe the pattern, we can say multiply by 2. Some patterns are a little different, like this pattern. We have 1, 4, 9, 16, and 25, and these are some special numbers because they're called perfect squares. So to get 1, we take 1 and square it. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and 25 is 5 squared. So this means that we are taking consecutive terms and squaring them. Consecutive means next to, so 1, 2, 3, 4, 5. So consecutive terms squared. We'll look at one more example where we're dealing with consecutive terms. Right here. So to go from 2 to 5, we're adding 3. 5 to 9, we're adding 4. 9 to 14, we're adding 5. 14 to 20, we're adding 6. 20 to 27, we're adding 7. So 3, 4, 5, 6, 7, these are consecutive integers. So we are actually adding consecutive integers to the previous term. We don't want to say we're adding 1 each time because we're not adding 1 each time. We're actually adding 3 and then adding 4, adding 5, and so on. And that's what a consecutive integer is.